So moving on here, I did leave these temperatures as the CSA defaults, 22 and 24. Next up, we have air tightness and infiltration. First of all, we need to tell this calculator what the environment is around our building. Obviously, a home that's on the water facing the ocean is going to be getting a lot more wind than a house that's in a standard flat subdivision with lots of other houses and trees in that nearby. So we should choose from these options here and best describe our building. I recommend that whenever we're making these choices, we err on the high side, if anything. By that, I just mean we err in the choice that will give us the higher loads. You can hover over this note here to read a little bit more about how to identify your shielding type. For a house in a standard flat subdivision with houses around it and some trees in the area, what we call the standard, you can choose suburban forest, very heavy for site shielding, wall shielding, and flue shielding. Do not change these values, or I guess this drop-down menu here, or the anemometer height unless we have known information about a local weather station. Next up, we need to define the air tightness of our building. This is a big factor in heat loss, especially, not so much of a factor in heat gain. Ideally, we use the first option here, which is blower door test results. Obviously, this is not possible if we're doing heat loss for a new home because the home isn't built yet. However, for existing homes, we can do a blower door test and we can get these numbers directly from the manometer or from a software that extrapolates data from the blower door. And you would get something like 5.135 ACH and an ELA of 212 square inches. Make note of the units here. This is imperial in inches squared. If you're getting centimeters squared from your manometer, you might need to convert, 988 centimeters squared into inches. If you don't have blower door test results, either because a test just wasn't performed or because it's a new building and the house doesn't even exist yet, you can choose this option here, which is an air tightness target. This is going to be less accurate because the equivalent leakage area is not going to be a measurement, it's going to be a mathematical guess, basically. You enter in the air tightness target here. For example, if it's a new house being built to step code 3, you would type in 2.5. And based on our volume, the equivalent leakage area would be calculated to be 37.3. You can enter in any value you want here. Give this section proper attention. Air tightness for existing homes, especially homes older than the year 2000, 1990, 1980. As we get older, air tightness plays a bigger and bigger factor in the heat loss for existing homes. Making the wrong air tightness assumption could result in a difference in heat loss of 10,000 BTUs or even much more than that. If the air tightness value is assumed, which it would be for any new home or for an existing home that no blower door test was performed on, you can type a Y in this field here. That will make note on the results page that this is an assumption. The third option here is just to select from a list of values. These are predefined air tightness values, and this is fine to do if you want to select from one of these 4 values, or you can just type whatever the target is in here. In our example here, the TECA in-class example, we're given air tightness information up top here. We can see the building is assumed to have a maximum air leakage of 1 air change per hour. So I can just type in 1 here, and that's that. Lastly, let's talk about venting and flue penetrations. So this is B venting. This would be anything that acts as a hole in our air barrier. Remember that direct venting, meaning sealed combustion, does not play a part in our air barrier. It does not affect our air barrier at all. So we do not include direct venting penetrations here. If you want to read more about penetration types, I recommend you read this cell here. You can also hover over this cell here to read about how to account for a fresh air intake into the furnace or heat pump air handler system. This is a common ventilation type and it's still allowed today, actually. which means a bath fan running continuously and a fresh air tie-in to the forced air return plenum.